example 2, we went to scientific notation. But in example 3, the idea is we can do the opposite. We can start with a number written in scientific notation and convert that back to the decimal format of that number. So let's go ahead and check that out. So in example 3a, we have 7.1 times 10 to the 5th. So I'm going to start off by writing down my 7.1. And then we have 10 to a positive power. That means that we're going to have a large number. So if we're going to have a large number, that means that I'm going to have to move my decimal to the right to get large numbers. If I went the other direction, I'd get small numbers. So how many times am I going to swoop to the right? 5 times. So 1, 2, 3, 4, 5. Now, the first time I swooped, we had an integer sitting there. But I'm going to have to write down a digit for all these other swoops. And in order to say that all those other swoops were just numbers that were sitting there in terms of swoops, I have to just come in and put some zeros there. They weren't the interesting ones. They were just the change the decimal point location idea. So when I look at this then, this ends up being 710,000. Well, as I look at 4.9 times 10 to the negative third, I once again want to move the decimal. But because this 10 is to a negative power, I need to move my decimal to the left. And I need to move it to the left 3 times. So 1, 2, 3. And there's my decimal point. And again, I have the 4 and the 9 that are the interesting digits. I need to fill in the rest of the swoops with some zeros just to demonstrate the idea that we did some swooping there. So we have 0.0049. Now personally, I also like to put in that 0 in the front just to make sure that the decimal doesn't get lost. So I'm going to put the 0 here as well. So we have 0.0049. And there's our answer for that one. Now, as you look at example 4, this idea of scientific notation actually allows us to do some calculations a little bit easier as well. So in example 4, I want to do this division problem, 0.0008 divided by 400. Now, I can do this problem by simply taking the 0.008, dividing it by a 400, and seeing what I end up getting. But if I move these numbers into the world of scientific notation, I can actually do this problem without a calculator. So let's try it. So 0.008, that's a number that I can rewrite in scientific notation. So it's going to be 8 times. And if I count out how many times I swoop, 1, 2, 3, 4 times. So that's going to be 10 to the negative 4th power. And then the same kind of thing in the denominator. I have the decimal after the 400, and I can swoop that over 1, 2 times, and we're at 4. So this is going to be 4 times 10 to the, well, 400 is a larger number, so it has to be a positive power on that 10. So it's 4 times 10 to the second. So my original problem is the same as 8 times 10 to the negative 4th divided by 4 times 10 to the second. Now, as I look at this problem, instead of thinking about it as a whole chunk of the numerator divided by a whole chunk of the denominator, we've seen that we can break these kinds of problems up. So I can think about this as the number in front on each one of these being divided times the tens being divided. Once I do that then, I've broken this up into 2 smaller problems that are a lot easier to play with. So 8 divided by 4, that's going to be 2. And then we have that multiplication. And then 10 to the negative 4th divided by 10 to the positive second. If I have 10 to the negative 4th divided by 10 to the positive second, there are lots of different ways that I can play with that. One is to say that this is an example of the quotient rule. So if we have the quotient rule, we need to do a subtraction. So it would be negative 4 minus 2. Negative 4 minus 2 is going to be negative 6. So our answer on this problem then is 2 times 10 to the negative 6th. Now, the other day I said that in general, you want to write down your answers so that you don't have negative exponents. Scientific notation is the one place where that statement actually doesn't apply. In scientific notation, it's perfectly acceptable to have negative exponents when you're done on your 10. So 10 to the negative 6th, that's a great place to go ahead and just leave that particular problem. So now that we have that answer then, we are done with our 2 parts for the lecture today. So you're ready to go ahead and check out worksheet 29 as well as the homeworks 29. Have fun.